How about now? Do I have audio now? I hope so. More tape. Yes, more tape and more coat hangers. Yeah, audio now. Good. Fantastic. I can't believe this contraption is working. I'm using the 8M, 2 copies of OBS running simultaneously on 2 different machines, and this is all going through, this is all being brought to you by the power of wireless internet. This is the router that the stream is running through right at this moment. How much data does it say I have? Oh, plenty. I've got 15 gig of data left on the plan. Okay. I've got a very different setup right now, so this is all going to be a terrible disaster. Good morning. I just saw Mitchell say where LTE is more stable than fiber. I don't have fiber. I've got crappy old twisted pair running through a pit that fills up with water every time it rains. It's not good at all. Where was I? I am so discombobulated. All right. First thing, I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, the way I I thought you were on coax. Stephen, you may be right. Yes, I am on coax. Yes, it's not twisted pair. No obvious lag. I can't believe that there is no obvious lag. That is crazy. I don't even know how to explain the setup that I'm running at the moment. I've got OBS on one laptop, which is feeding into the 8M. The 8M is connected by USB to a second laptop and running as a webcam. And then on that second laptop, I'm running OBS. And that laptop is connected by Wi-Fi to the little 4G dongle thingy. It is a... the other thing is how many batteries are involved in this. So the wireless microphone that I'm wearing, battery on the transmitter, battery on the receiver going into the 8M. I'm on a laptop on battery right now. I don't have the power supply for it with me. And it's going through a battery-powered wireless 4G router. Yeah. So, Amanda said, Happy Mother's Day to those of us that are mothers here on the stream. Yes, Happy Mother's Day. I'm going to be going up to visit my mum this afternoon, and that should be nice. Hang on, I've just got to get myself organised. So you probably noticed that I am looking very down at the moment compared to where the camera actually is. Let's, I'm just going to try changing to that. I don't know if this is going to be better or worse. At least it'll look like I'm looking at you. This is now running the internal camera on the second laptop. All right. Where is it? Pop out chat, that's what I want to do. I want to get the chat out here so I can see it. Oh, Chip says, say hi to your mum for me. I will. And vice versa, you say hi to your mum as well. Now, what has been going on? Yes, a couple of people mentioned what are basically like dream streaming setups for this sort of situation. Michael and Amanda both talked about setting up dual 5G Telstra modems and running behind a router, blah, etc. Yeah, that would be the dream. Costs a fair bit though for a 5G connection. So, and then 2 5G connections, even more. Where are we today? Where are we? Okay. Now you're looking down on us, says Mitchell. Okay. Oh, Dentistry's had an interesting question. And yes, I do have experience with making an Ethernet switch. And maybe that is something to talk about today. Let's... something just went bong.
I'm having trouble connecting to the internet.
Yes, yes, be quiet.
It looks like there's an issue with
Alexa,
the
stop.
and Echo device, so try restarting them. Unplug both of them and plug the router back in.
Alexa, stop.
Wait 30 seconds. Once the router is back,
It's not listening to me. Because the internet is down, Alexa is complaining, and it does this long spiel about how to debug the problem, telling me to restart my router and those sorts of things. But because it's offline, it can't hear me. It can't understand me. It hears the wake word, but it can't understand me telling it to stop, so it just gives me the long spiel. Okay. Where was I? Ethernet. Okay. All right, I'm going to try... This is so bad today, so random. Right, I'm going to go back to running the stuff through the ATEM, because I can then do things like this and pull up stuff on the screen. And if we're going to talk about technical stuff, I need to be able to show you things. Now, oh, actually, while I'm here, where's my other keyboard? I've got to move that keyboard out of the way. Let's do it. Nope, I still can't ping. So, I do not yet have my internet connection back. All right, back to the chat on this computer. And, all right, Austin says, hello, I see we have internet. Well, kind of. I have mobile internet. I'm running through a little Wi-Fi 4G internet thing. Dodgy said, has everyone got this weird new view on YouTube, or is there a setting I need to change? Camera is struggling with the lights behind. Yeah, I think we're better off with this front camera. It's just that my chat window is way down low, and it's not anywhere near the camera that I'm looking at. But we can live with that. Okay, I wonder if I can open Eagle. That would be interesting, because I hope I don't have to sign in. No, I don't. That's good. What's really annoying is when I need to open Eagle and I'm offline and it says you must sign in, which is really, really painful. Now, did I do an Ethernet, ether? I can't remember if I started designing an Ethernet switch. Now, I did work on an Ethernet switch a while ago. Oh, hang on. Right now I'm just scrolling through... Oh, is that it? No, that's not it. I'm just scrolling through projects in Eagle, looking at what might be useful, because I want to give a proper answer. Where is it? Yes, cloud dependent software, says Scott. Sorry, I haven't said hello to everybody this morning. I'm too turned around. So let's see what I can find. All right, let's see. No, I'm looking for design files. No. Okay, I'm wanting how to do this. There's a... Just gonna see if I can open the data sheet. Okay, this data sheet. This is from a project that I did some consulting on a couple of years ago, and it was for an Ethernet switch with an unusual power over Ethernet system. And this particular project didn't go anywhere as far as I know. It was done under NDA, so I'm not going to show you all the different things that were specific to the project or the design files and that sort of thing. I may have part of a schematic that I can show without being too, without being in breach of, where are we, demo schematic. This might be useful. Let's see if, I don't even know what format this is in. Hang on, I've just got to get a folder open so I can get myself organized and start talking in a way that makes sense. Oh, I keep getting confused because I'm switching between two different computers. All right, new, find a window, and where is it? Dropbox, clients, where is the clients folder? There it is. Okay. Schematic design guidelines. U-clamp, no, that's not it. Is this it? No, that's an Ethernet protection thing. Sorry, I am all over the place. All right, datasheet, hard reference schematics. Okay. Maybe this will help. Okay, this will help with this question as well. Reference schematics. All right, now that I've got myself kind of organized, let's get back to what this question was. Alrighty. Now, right. So, where was it? I've lost track of what was going on. Who was it that asked about Ethernet? Was it Mitchell? I think it might have been Mitchell. Oh, no, it's dentistries. Okay. So, I can do some more explaining. Looking to put together a reference design for an unmanaged switch that I can use for a few projects. Yes, okay, cool. Hopefully we've got ourselves all sorted now. So, let's get back to this. All right. I am very interested in what you are selling, and I wish to subscribe to your newsletter. Now, over the years, backing up a bit, the idea of making your own Ethernet switch to me has seemed like a really daunting thing. It's been something that just seemed totally out of reach, and like I could never even really conceive of doing it myself. And then a few years ago, I did some contracting for a company in Brisbane, and I'm not sure if I should mention who they are or not. I don't know, it's probably fine. This was for a project where there was a custom Ethernet switch being delivered because there were sensors being deployed in an industrial environment, and each of the sensor boards was connected over Ethernet and powered by PoE, but they were low voltage PoE. It was basically, from memory, I think it was 12 volts being sent down each of the network segments. And one of the requirements for the project was to be able to individually control PoE on each of those segments so that they could be power cycled. And my client in Queensland had worked on a prototype for this design, run into some problems, and couldn't get the Ethernet switch to work. So they designed this custom Ethernet switch that would go into an industrial enclosure, and it had the correct number of ports on it for what they needed to do, etc. It was a switch specifically designed for that application. And so they contracted me to try to figure out what was wrong with it. They had a prototype that was assembled but not working. And then so they sent me an assembled prototype and schematics and all those sorts of things, the information about what it was meant to be doing. And once I started digging into it, I discovered that making an Ethernet switch, at least if you only want to go to like 100 megabit, it's really not that hard as long as you're reasonably careful about tracks and routing and those sorts of things. You can design your own Ethernet switch, and there are chips out there that will make it really not that hard. They take care of most of it for you. So, and there are good reference designs as well. So in that particular project, it was using the KS8999 Ethernet controller. Basically it was an Ethernet switch in a chip, and it just needed a number of other things added to it to make it useful. So functional diagram, so this is the datasheet from that Microl KS8999. I'm not even sure if this is a current switch. Like, how old is this? Is there a date on this? January 2005, look at this. So this is a very, very old Ethernet switch chip, but if you only need 100 megabit per second, then this is, I don't know, it's probably still available. On the computer that you're looking at right now, I don't have internet access. I'm capturing this screen, but I can't even look anything up, so I can't see whether whether this chip is currently still available or what its price is or anything like that. Maybe someone can look up KS8999. Yeah, that's right. So Stephen W said, looking inside basic and cheap gigabit switches, almost everything is done in the silicon these days to reduce cost. So what this got me thinking about, and to wrap up that story, so I found the problem with the design and patched the prototype circuit board and got it all working. So we got the Ethernet switch working with low voltage PoE injected onto each of the segments and control of power on each of the segments. And it was a kind of modular design, so there was a little daughter board that would plug in for each segment to allow it to do different types of PoE. And the plug-in control board that they were using was just for low voltage PoE. Scott says around $15 per. Madtech, he says obsolete. Yeah, cool. Well, there are probably better chips to use these days. So, because this is the chip that I've got the datasheet for already on my computer without having to look anything up, and it's the one that we used in that project. And for the purposes of this conversation, this is perfectly adequate. We can go through this. Functional diagram. So we don't really care all that much about the functional diagram of what's going on inside it. It's got control over the different ports, and so it's got these little sections. Lookup engine, 1K entry, so that'll be for the ARP table, I guess. And then there's queue priority management, buffer management, SRAM buffers, and then there'll be this internal internal bus in here where it allows you, where the chipset can route data between different ports. So you can send data in one port and have it come out another port. Then it's got this control interface on here, I think it is. So then there, and LEDs. So there are outputs for status LEDs for each of the network segments. EEPROM processor interface, I2C. So So it's a 9-port, 8 plus 1, 10100 integrated switch with 8 physical layer transceivers and 1 MII SNI interface. And let's look at some, we'll look at an example schematic in a minute. What have we got there? I'm just scrolling down through the datasheet to see if there's anything else interesting. It's just lots of pinout stuff. There'll be registers and and things further down if we get that far. Oh, look, there's the pin configuration. One thing that really sucks about these is that they just have a god-awful number of pins on them. So how many is this? 157? 200, it's a 208 pin PQFP. And that is for an 8 plus 1 port Ethernet switch. So even with a relatively small number of ports, they just have this stupidly high pin count, which can be a real pain if you're assembling a few of these things by hand and you're having to do it yourself. But there's not really a way to get around it, because there is just the necessity for that many pins. If you've got that many interfaces and each Ethernet interface requires a certain number of pins, and you've got, like, look at this, all of these LED connections here, more LED connections, there's a bunch of ground pins, more LED connections down here, mode cell, so mode pins, all sorts of special purpose pins, what else do we have, etc. Yeah, there are just a lot of pins. So that is one of the annoying things about making an Ethernet switch, is just that there are so many signals to deal with. But in terms of how, apart from that, the very large number of pins, where is the other thing? Oh yeah, here we go. This is the other, this is the reference schematic from, who makes that thing? The KS, I can't even remember the company that made it. So this is an example schematic for it. And what can we look at in here that's useful or interesting? Let's see. Well, we can see here, for example, we've got RxM4, RxP4, so that's minus and plus, and then, so we've got 3, 4, and then we've got Rx, basically Rx and TX, positive and negative for each of the ports. So there's port 3, port 4, port 5, port 6, etc. And then if you connect that through, I'm pretty sure this chip, you need external magnetics to run with this. So you need, which will be somewhere in here. Do we have an example? Oh, yeah, there are the LEDs for all the status indication. Yeah, there's just a lot of stuff. The thing is that none of it is particularly, complicated. It's just repeated a lot of times. You've got 8 ports, and so everything just becomes, it feels overwhelming because there is so much of it. But if you look at any one individual port, they're not really that complicated. There's not that much to it. So yeah, it can be quite a routing job, but it is very repetitive. It's very methodical. So if you've got the structure for one of your Ethernet interfaces sorted out, then you can route, just keep duplicating, do the same thing over and over again. So coming back to this original question, oh, Stephen W. said 90 pins just for Ethernet signal and LEDs. Yeah. Okay, oh, Michael said, oh no, for a moment I thought Michael was providing a pin number for an alternative part because it was in all capitals. No, it's just Pinapalooza. Yeah. Oh, Paul suggests that KSZ 8999I or 1 is the current part. Could be. Micrel themselves say 266,110 in stock at $30 per part, according to Octopart. Yeah. So there's microchip technology, Michael pointed out. So this is not necessarily the part that I would use if I was going to design an Ethernet switch myself today. But it's the one that was used on this project a few years ago, and the cost is not insignificant as well. When you start getting into this, it becomes even more impressive that you can buy an Ethernet switch for such a remarkably low price. Like you can walk into an Officeworks or some bargain computer shop and buy a little 8-port Ethernet switch for basically the cost of of parts for of what you could do this. Imogen, you're participating. Good. So now I have, getting back to the start of this, when I worked on this project, it made me realize that designing an Ethernet switch for a custom application is not beyond the realms of possibility. It is actually something that can be done. And it's been on my kind of wish list of things to do for a long time, because I really like the idea of designing an Ethernet switch with built-in with built-in control of PoE on all of the ports. Oh, Mad Techie said, so did you find out why it wasn't working? Yes, I did. I figured out what the problem was. It turned out to, this is going from memory from a few years ago, but I think it turned out to be a misconfiguration on mode pins, because the somewhere around here there are the mode cell pins. Oh, they were in the other, we were looking at them in the other data sheet. This one. There are these pins here, mode cell 0 through 3, and there were a couple of other pins. There's config mode and a few others that allow you to do things that control how the chip boots. I may be totally sending you off down the wrong path here, but it was something to do with the chip not initializing properly, and I can't remember what it was specifically. Like, I can't remember the actual exact problem, but it was something like it was not booting in the correct mode. So I had to change some mode pin settings, and then it all came to life and it worked. So that was cool. Dodgy asked, why would a router need so many LED pins? Typically because they want to show that there is a physical connection on each port and the speed at which each port connects. And then the speed, sometimes, I can't remember on this particular one, but where is, let's go back to the other thing here. Where are the LEDs? LEDs? Somewhere. Where are the LEDs? Oh, there. Oh, those are resistor networks. Okay. So D5, I can't see what these are, what the purpose of these is. But we've got how many? 1, 2, 3, 4, 5 by 4. So there are 20 LEDs there. And I don't think that'll be all of them. Why are there 20? That seems like an odd number. Oh, there are more there, of course. So there are another 16 there. Yeah, so often there will be 2 LEDs per port, but there may be more. There could be panel LEDs, there could be, so there can be an indication of physical connection, there can be an indication of the speed, there can be activity LEDs. Often the activity LED is combined with the speed display, so the LED flickers with activity. But yeah, there can be a lot of LEDs. Yeah, Madteki says some are bicolor, so max of 4 lines per port. Yeah. RXTX, yeah, I can't remember what this specific thing is. And the thing is, I probably wouldn't even connect all of those LEDs if that's not necessary. They can either be LEDs that are on the PCB so that they are visible in the front panel, or they can be in the RJ45 socket, actually integrated into the socket itself, which I much prefer. I really don't like it when the LEDs are on a separate little panel off beside it, because you've got to look across and go, oh, which one is plugged in? Port 5 is plugged in, and over there, port 5 is that LED showing activity. So yeah, it's better when the LED is right at the port and you can see the activity. Now, question is, Dentistries, what are you wanting to do with an Ethernet switch? And yeah, Scott says, my current main switch has the LEDs in the sockets and an array of LEDs off to the side. Yep. Yeah, so, Dentistries, was there something in particular that you wanted that is not in an off-the-shelf switch? Or are you wanting to do something like integrate a switch into another project that you're working on? Because that's one of the things where this can be useful as well. If you've got an object that you're working, a project that you're working on, and it's not specifically an Ethernet switch, but having multiple Ethernet ports available on it is useful, then building a switch into it can be a way to achieve that. Yeah. So in the same way, the other thing is USB hubs. Same sort of thing. You can build a USB hub into a project, and yeah, so you can make it's a little bit like Austin's USB hub project. Okay. Interesting, Dentistries. First one, I'm redoing my lab workshop, and at the moment I have a USB network around the lab. I want to join this with an Ethernet network. I've made USB hubs that fit in black boxes. Want to do the same with Ethernet so I can daisy chain instead of running back to a patch panel. Okay. Now, daisy chaining Ethernet switches, that is that's a whole other conversation. But yeah, I do like this idea, and I like the idea of making a USB hub so that you've got things like control over power, and you can do power monitoring on every port, and also making your own Ethernet switches for the same reason. So you could do power monitoring. I mean, you can already buy these, obviously. If you go out and buy a commercial Ethernet switch, you can get one with PoE that's controllable, but there is but often they are wrapped up in a specific ecosystem, like in the Unify ecosystem or the Cisco ecosystem. So they aren't really designed to be controlled directly from something that, with a basic API or with digital inputs, for example, or over USB. So having something like an Ethernet switch with a USB interface, possibly with a microcontroller in it, so that it exposes the USB interface and takes care of talking to the Ethernet controller, would be a good way to do it. Yeah, managed switch that talks MQTT, exactly. Scott, that is exactly the sort of thing that I'd like to be able to do. USB hub that talks MQTT, Ethernet switch that talks MQTT. And you could put something like an ESP32 inside the Ethernet switch, and then the switch itself could have Wi-Fi with the ESP32, and also have, obviously through its own networking, what you could do is dedicate one of the ports from the Ethernet switch to the ESP32. So when you plug the Ethernet switch in, it could expose, say, 7 regular Ethernet ports on sockets on the front, and have the ESP32 come up as a device on the network, and it could provide PoE with full power switching and power monitoring on each of the network segments, and a USB interface. So it will give a huge amount of flexibility. I really like the idea of a project like that. Yeah, Andrew says some data center grade switches can run virtual machines on them. A number just run Debian. Yeah. Yes. So that's the way it is with a whole lot of high-end equipment. It's basically a computer with specific I/O. So a router is basically a computer with specific I/O. Ethernet switches are a computer with specific I/O. Yeah, Scott says, that's it. I need a dozen 24-port switches built this way. Oh, Dentistry said, explain the other projects above. I think I missed some of your comments. All right, so I'm going to go back. Yeah, Scott said, OXRS rack cabinet with an 8-port switch built in. Yeah, that's right. I'd like to be able to do something like it'd be nice to be able to do an OXRS 1U module, which could have something like a Raspberry Pi inside it and an Ethernet switch. So one of the things that I've done in the past is decase Ethernet switches and mount them in inside new enclosures. Like, you can get little desktop Ethernet switches like the Netgear Ethernet switches, and then mount them inside just inside a 1U enclosure. Which reminds me, there was that video a few days ago of, what's his name? I can't remember. I've got that blank thing happening. The guy who took a Unify Dream Machine and a Unify aggregation switch, and he pulled the guts out of the aggregation switch and put it inside the Dream Machine. So it became a Unify Dream Machine with 8 10 gigabit Ethernet ports built in, and just bridged them off with an SFP, a short SFP lead between the two of them. So doing that sort of combined device is really interesting, where you've got the functionality of something equivalent to the Unified Dream Machine. You've got the processor and the storage, and you can run virtual machines and do all of the management side, and also have, say, an 8-port aggregation switch built into it, which then everything else cascades into. Scott says, just say no to RPi, micro ITX with an i3. Yeah, something like that would be much more grunty and allow you to run more mainstream, I suppose you could put it. So you could just run like a stock Debian on it or Ubuntu and run some virtual machines on it. Now, I've got to go back and find Dentistry's comments now. So there was the Ethernet. Okay, so also looking at a few robotics projects, and a company I spoke with made distributed motor drivers that work over Ethernet with a sort of pass-through using built-in switches. I'm not sure it's the best way of doing it, but I thought it would be fun to try. Yeah, that's cool. Plus a few home automation projects where I want to have the pass-through option using a switch. Yeah, cool. Thanks for explaining that. Now, I raised a moment ago the issue of cascading or daisy chaining. And Andrew pointed out, where was it? Scrolling back here. For daisy chaining Ethernet, remember the 543 rule. Although 543 isn't so much an issue anymore, you can still get interesting issues if you have too many hops. Yeah, so that's the issue, is having, when pass-through is essentially just daisy chaining. It's when you have an Ethernet switch with a connection to another Ethernet switch, which connects to another Ethernet switch, which connects to another Ethernet switch. So when you want to send data across the network, it might have to traverse many switches to get to its destination. And the general principle, of course, is not to have too many hops, and instead to use something like a high-speed aggregation switch. So in like small to medium offices, typically there will be something like a 10 gigabit aggregation switch, which might have 8 or 16 ports, and then there would be 10 gig connections to a number of distribution switches, and then from there they might go out to other like end switches that are on the edge of the network, and that's what all the devices plug into. So a lot of the time data can be localized. You need to keep it as localized as possible, but it can move back all the way up to the aggregation switch, which provides the high bandwidth connectivity between the distribution switches. Anyway, lots of hand waving, and there are people who know far more about that than me. But the general principle is to keep, to make a tree that is not very high. You don't want to have lots and lots of things all daisy chained off each other. It's better to make the tree wide with high-speed aggregation. That's not getting into any of the issues of redundancy and that sort of thing, of course. This is just like a vague general principle. All right. Oh, Tassie Bob says some of the data center stuff, like Arista as an example, has FPGAs on board for running custom applications like high-frequency trading. Really? HFT on an Ethernet switch? Interesting idea. Yeah, Stephen says, I knew the local rep for EnterAssist before they got bought out by Extreme Networks. They had a switch with a PC built in back in the early aughts. Oh, Crosstalk Solutions. Yes, Peter. Thank you, Peter. It was Crosstalk Solutions who did the video. I think it was only a few days ago. It was a fairly recent one about combining the Unify Dream Machine and the Unify aggregation switch. Yes. Oh, and Killer Geek said the same thing as well. Yeah. Andrew Cochran said layer 3 switch. Okay, so layers. Networking layers. It's years since I have done networking stuff other than really basic, just plugging stuff in. So I am not the person to be explaining all of the different network layers, like layer 2 versus layer 3, etc. Yeah, that is... Yeah, I won't get into that because I don't know enough about it to say anything sensible. And there are people here in the chat who know way more than I do. So getting back to this, this is where I get into one of those error, too many project situations. Actually, I'm just going to have a quick look. I want to see if... Oh, that's not too bad. I've used a gig of data, I think, so far doing this stream. So I think I'm going to be okay for data. And as long as I'm not getting any weird things. So I'm curious to know, is anybody getting lag or there hasn't been any buffering or anything like that? I am really tempted to just use 4G in future because NBN is so bad for streaming. It's horrible. Okay, so Martin says layer 3 means it can look at IP address and not just the Ethernet MAC address. Yes. So, smooth as butter, says Gerald. Thank you very much. Keith said, let's make a switch in a future video. Imogen can solder it for us. Yes. So, yeah, this is the error too many projects situation. I really like the idea of making an Ethernet switch. I think it would be an interesting collaborative sort of project. And I'd like to do a switch. Somewhere in here there were some control pins. Yeah, I'd like to do it as a collaborative project, but I fall into this error too many projects trap, and I still have the Wi-Fi access point that I want to get back to. I haven't looked at that in months, and I need to make progress on that. And if I can't design an access point, then I really shouldn't be trying to design an Ethernet switch. Now, those comments about layer 2 versus layer 3. Yes, so layer 2 is the signaling level. Layer 3 is the addressing level, says Michael. Right, so with a basic switch that is layer 2, hopefully I'm explaining this correctly, layer 2 understands the MAC address level. So it knows that, for example, this particular connection, or this particular device has this MAC address and it's plugged into port 2, and this particular device has this MAC address and it's plugged into port 3, and it can pass data between them. So it knows if the destination of that traffic is that MAC address, then it can send it. With layer 3, it is the next layer up where IP addressing comes in, and that is where it, I think it's kind of bordering on router territory, but without all of the control that a router can do. So it can look at an IP address and say, oh, that IP address has to go to that port. Something like that. Anyway. Right. Oh, good. Imogen says, Keith, I'm down. Yes. So what we need to do is do some design of an Ethernet switch, and then we'll make sure that Imi is here on a day that we're going to assemble it. She can do some of the soldering. So Mitchell says, think about it this way. The access point needs to be powered, controlled, and set up from the switch. So you need to finish the switch to finish the AP. Yes, that is actually one of the reasons that it ties in. And working on the access point project, it really got me thinking more about doing an Ethernet switch, and it is for exactly that reason. It's because if we do our own OXRS Wi-Fi access point, it has to plug into something. And what is it going to plug into? At the moment, I'm using UniFi switches, but I would love to have an Ethernet switch, which is the OXRS equivalent of a UniFi switch, or Cisco, or any of these more upmarket things than just your basic consumer unmanaged switch, but the OXRS version of it, so that all of the statistics, all of the port management, all of that sort of thing comes back into the OXRS interface. That would be so cool. And we could do, as Mitchell said, was it Mitchell? Yes, Mitchell said, the access point needs to plug into a switch. So it could be an OXRS access point, which is managed, plugged into an OXRS Ethernet switch. Yeah. Oh, Chip says it'll have to coincide with a barbecue. Definitely. And Dentistry says, just blame me for giving you extra projects. Yeah. I don't need any help with extra projects. I've got way too many already. Stephen W. says, for simplicity in the project, you can just use an open source firewall OS to handle layer 7. Yeah, so what would be really cool, what I've had in mind is once it gets to this point, rather than, there is no point trying to do something like create new firewall software from scratch. That's just like a crazy task. what would be more interesting is using something like OpenWRT or pfSense or whatever the preferred thing is, and setting and adding support for that in the OXRS management system, so that we could have something like a pfSense firewall which is managed through the same interface as the access points and the Ethernet switches and light switches and smoke detectors and everything else. So it becomes a complete ecosystem. Ooh, okay, so Imi said, okay, now I have a circuit to have a look at too. I got my blue tongue lizard last week, and when I plugged his thermostat in, boy did the smoke come out, orange spark and all. I want to investigate. Well, something's gone really bad. Yeah, Austin says, adding things to OXRS interfaces is easy. It's all based on JSON payloads. Yeah, and Stephen pointed out that allows you to have a managed layer 2 switch, and that's basically all that's required. Right, okay, so what do we want to talk about from here? Maybe, hang on, let's, oh, where's my other keyboard? Is that it? No, not that. I want to go to that. Oh, look. It looks like NBN is back. There are pings happening. I'm not going to change anything about it, but at least that means that I can now look things up on this computer. So, to do that, I need to get a different keyboard, because I got my laptop in front of me where the keyboard for my desktop computer is normally located. So let's have a look at Ethernet chipset, Ethernet controllers, Ethernet switch chipset. Let's see, Ethernet switches, microchip. Mouser has a few listed. Let's look at microchip to start with. Oh, look, we've got these KS series. So in production, automotive 100. One of the issues though is 10100 enough. I have a feeling that for many people it won't be. It would be really nice to do gigabit at the very least, and I'd rather not do QFN, I'd rather do QFP. So what have we got here? In production, how many, is that ports? Yes, that's port count on there. Let's, do they have a filter on this? View all parametrics. Yes. Let's look for a automotive, don't care. Port speeds, whatever. Temperature range, number of ports. Okay, minimum. Let's take the minimum number of ports up to 8. And, oh, there are only 9 products still. No, not only 9. Okay, 9 of 9 selected. And speed, we want, we don't need 2.5 gig, that's kind of overkill. Let's go for this. And has that narrowed it down? Okay, so we now have 4 options. And we have number of ports. Let's look at the smallest one. There's a 10 port switch here, because I think it'd be kind of overwhelming to go for more than 10 ports. Oh, Austin says, you like QFP? I'm QFN all the way. No, I hate soldering QFNs. And look, it's going to get worse. I think this is going to, yeah, BGA. I'd really rather not. If someone else is assembling it, sure. But if I am, yeah, I'd rather not. Oh, Amanda says 2.5 gigabit minimal. Okay. Let's go back to here and add that one. turn off that one. What's the difference between that and that? Why are there two there that are 10, 100, 1000, 2500? I don't know. But anyway. And let's reduce the maximum number of ports because 64 ports is a little bit overwhelming. Let's go for a maximum of 16 ports. Okay, so these are our options. Even so, these are going to be kind of nuts. 8 port. There are a couple of 8 port. So what have we got? Automotive, no. Wake on land, no. Max temperature range. It's 85 degrees versus 125. HSBGA, PBGA 256. Yeah, at this sort of level, it's not going to be. We're not going to be able to avoid BGA. So 8 port TSN gigabit switch. Does this have 2.5 gig? It came up as having 2.5. Oh yeah, it does. Okay, but is it only on one port? Is it just like an uplink port, or is it across all ports that it supports that? Copper support, fiber support. Okay. I think that this is going to be biting off more than I can chew. I'm sure there are many people here in the chat who could design something based around this, but it feels like a bridge too far to me. But let's have a look anyway. Well, purchase options. How much? Order now estimated to ship November 2023. So buy now price $33. What is that? I don't know what the difference is. I'm not really interested right now, but it's in the $30 region per chip, which is not too bad. That's kind of acceptable. So let's go back to here. I'm going to go back to this and hang on. Yeah. Oh, there were more options here. That was weird. All right, so we've got 10, 100 there. We've got another 10, 100, 1000 there. Their internal thing is a little bit strange. Hang on, why has that narrowed it down? Why did that narrow? Oh, there's nothing in that one? I don't know what's going on with their filter here. I'm just going to leave it as, no, not that one, and that one. Okay, so up to 1 gigabit. Why is there only one showing up now? I don't know. Doesn't matter. This'll do. It's the same one we had open earlier. It's this one. So 10 port layer 2 switch with 8 copper PHYs. Datasheet. Yes. Let's have a look at this crazy datasheet. Yeah, so Scott points out chip is roughly the same price as a basic 8 port switch. Yes. Now Austin says if doing level 3, 10 gig and 2.5 gig, yes, 2.5 gig is good for newer Wi-Fi 6E APs, but otherwise better off with 10, 100, 1000. Might be an SFP. Okay. Oh, need 24 ports, says Dodgy. Yeah, I am trying to do a let's not bite off more than I can chew sort of thing as a starting point, just to get, just to not be daunted by this. Now, first point of dauntedness, 772 pages in this data sheet. Great. Now, let's have a look at some pins. And yeah, come on. We're still in the index. Come on, we can get there. Fields. Yeah, all the registers and fields and things. And now we're down to the revision history, and we're on page 32. Okay, let's see if we can find. I wonder if they've got some kind of a reference design. Maybe. All 1 gig Ethernet ports are tri-speed, integrated copper transceivers, blah 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 blah. 8K MAC address table for the ARP table, multicast security. So when I see something like this, I am daunted by it, and I wonder why it's worth the effort, and whether it's better to reuse something existing, like find an existing gigabit Ethernet switch and modify it, or port numbering, port MAC. Yeah. Let's go back to the table of contents and see what we can find for. No, that jumped. I clicked on something by mistake. What I'm looking for is pin diagram. Okie dokie. Let's just pick one. I don't care which one. First one. Pin diagram for this one. Okay, so VSS, VDD, lots of duplicated pins there, which is good. Some GPIOs. Top left, top right, and lots of reserved, which is also good. What I'm wanting to do is eliminate all of the individual signals. The other thing that's an issue with this, in terms of assembly, if I'm going to be assembling these myself, typically what you need is decoupling capacitors on the back of the PCB, because you got all of these VDD and VSS connections through here, and often, ideally, you want to be able to put decoupling caps near every few connections, and that means putting them on the back of the PCB, because you can't practically route these connections out from the BGA and put all the decoupling caps on the same side of the board around the chip. They need to go on the back of the chip. And I do everything I possibly can to avoid double-sided loads when I'm assembling it myself. So yeah. So those are the two halves of the pin diagram. They've just split it because it doesn't fit. So the device has 672 pins, and information provided isn't attached as a Microsoft Excel file. That's nice of them. Alright, so this is rows A through AF and columns 1 through 13, and then we've got rows A through AF, columns 14 through 26. So how many is AF? I don't know. I should know. So that's 26, 27, 28, 29, 30, 31, 32. So it is, hang on, TUVW. Why is there no X and no Z? That's odd. Okay, so it looks like it's at 20, is that 26 by 26? What is 672 divided by 26? 672 divided by 26 is 25.8 something. Alright, it's missing a couple of pins in the corners, but it's basically a grid of 26 by 26. So that's half of the pins, or the balls rather, and that is the other half. So those are all the connections that need to be made to it. But reserved, provided they don't need to be tied to ground or anything like that, they can all be eliminated, so you can ignore all of those. A lot of these, like you can see a lot of VDD pins here in yellow and VSS in green, those are generally pretty much tied together, apart from having grouped decoupling caps for them. Then there's a bunch of GPIOs, many of which we probably won't use unless they are used for LEDs. And then across here you can see, if we zoom in a bit more, you can see P5, D0P, P5, D1P, D2P, D3P, and then the corresponding N. So that's positive and negative, and that is port 5, data 0, data 1, data 2, data 3. So those 8, those 4 pins there and the 4 pins below them, those 8, are the pins that go to port 5. And then over here we can see the pins that go to port 4, and then the pins that go to port 3, etc. So that's not too bad. It's basically just a set of 8 pins going to each of the ports, and they're grouped around the edge of the chip, which is nice. And we can see here there's port 0 going up here, port 1, port 2, port 3. It's going counterclockwise around the top right edge of the chip. And then if we go back to the other part of it, we can see the ports continue along here, port 6, 7. So all 8 Ethernet ports are around that edge of the chip. Then there's a bunch reserved. I'm talking myself into this. The more I look at this, the less daunting it seems. So the actual I/O pins, the pins for the Ethernet ports are not that bad. It's just the 2 outer layers of pins around that part of the chip. But then we've got, there's some DDR. I wonder if it needs the DDR memory, or if it can work entirely off internal memory. I don't know why they would have that. Maybe someone else knows. SerDes, so we've got some SerDes connections down here. These ones here, and more reserved. It's not that bad. I could imagine myself routing this. So, okay. Right. Mitchell says, start small, 5 or 8 port and work your way up. Less massive start. Yeah, that's the thing, is if I tried to bite off something like doing a 24 port gigabit switch, I think it would break my mind. It would just seem like too much of a leap. What I'd like to do is start with something small, like doing a switch perhaps with 7 ports, and use one of the ports internally to connect to an onboard processor, like an ESP32, so that it could do stuff like power management for PoE on each of the ports, and then prove the idea at a small scale, and then maybe it would then be less daunting to expand it out to something else. But just the cost of doing this is a bit of a pain as well. So it's expensive. There's a lot of time involved in laying out a board like this, like routing that BGA out, and expense in parts and things too. So yeah, I don't know. Yes. All right. What's happening in the chat? Killer Geek says, if you want a simple and easy to work with switch chip, get IP175G. You can find these in a lot of the 5-port mini switches. Cool. That's a good tip. Thanks, Killer Geek. So that's the MikroTik. When it's this many, Stephen says when it's this many pins on BGA, it's basically certain to want double-sided load. Yep, Stephen says, did I see a pin label for a DDR chip? Yes, you did. You saw, where was it? It was on the right-hand half, on here, down here. So DDR stuff all through here. Now, hopefully that doesn't actually need to be used, and that it is so that this chip can support an external DDR memory chip if necessary, but you don't have to do it just to make it work. A tourist said maybe some open hardware designs exist to use with Facebook Open Switching System, FBOSS. Maybe. I don't know. That's worth looking for. And tourist also said for the software you could build on top of Facebook Open Switching Systems. I haven't actually heard of FBOSS before. I've heard of the I can't even remember what it's called, but there's the open data center stuff that a number of companies were collaborating on. A few years ago, it got a bit of press, and then I haven't heard anything about it recently. The open data center stuff, which was for design of racks and servers and power supplies and those sorts of things. So that each company, all of the really big players, wouldn't have to be reinventing the wheel to build out data centers. And Austin, thank you for the $5 Canadian for the Ethernet fund. Yeah. Open Compute Project. Thanks, Andrew. Yes, I think that was the thing that I was thinking of. Oh, Mitchell says there's also a new one, TIP, the Open Switch Platform. I've never heard about that one. The Open Switch Platform. Let's see what Open Switch Platform is. Oh, wrong keyboard again. Open Switch Platform. I've got a Open Switch Platform. I'm very confused today because of my weird setup. OPX, Open Switch. It's a Linux Foundation project. Alrighty then. OPX, Network Operating System, new way to build composable networks. I've never heard of this one. What is OPX NOS? Network agility, open source disaggregated network, build composable networks. Okay. I still don't even know what it is, but it sounds like it's something that could be useful. Mitchell says not that one, but that is one. Okay, so TIP, Open Switch Platform. Let's see if I can find that specifically. TIP, Open Switch Platform. See if I can find the one that you're... Open vSwitch? No. That... Is it Open vSwitch? Open Switch. What is the difference between Open Switch and Open vSwitch? Open Switch installation guide and useful tips. Is this the one that you are talking about? Netberg Open Switch. Download the ISO image. What is this from? Custom networking switches, server storage. Open Switch. I don't know. I don't know what I'm looking at. Telecom Infra Project, Open Wi-Fi. Okay. Let's try that one. Mitchell says no, but I guess maybe that is another one too. Telecom Infra Project. So that'll be what TIP is about. Telecom Infra Project, Open Wi-Fi. Aha. Now I'm pretty sure I've got the correct thing. Open Wi-Fi. Industry movement for accelerating Wi-Fi infrastructure innovation. And I have a feeling that this may have been mentioned previously and it just got flushed out of my brain somehow. The classic thing. But this is... yeah. This is the sort of thing I could sit there and read about for ages to learn about, and it's probably not something to go into on a live stream. Mitchell, you can't send links. Hang on, I'm going to fix that. Yes, so Mitchell, now you should be able to send links. Yeah, Scott says looks to be completely Wi-Fi targeted. Yeah. Yeah. Okay. So Andrew said for hardware that feels like it didn't meet a bunch of the wants, MikroTik RB5009 UP etc. does look rather interesting. I'm using a slightly different model for my home routers, still with OpenWRT. Yeah. That is interesting, yes. This is getting into an area that, I don't know. It is interesting, but it is also a very deep and very wide pool to dive into. If I dive into this, I could drown. There is so much to it, and I would totally lose track of all of the other things that I'm doing. So, hang on. Please excuse me for a second. I think I need a refreshment break. Better. Much better. Yes. Okay, so, Tura said, White Rabbit switch is an open hardware design for an 18-port Ethernet switch licensed under CERN 12. It is a central element of a White Rabbit network and was designed as a part of it. Oh. Yeah. Mitchell said we could just use a MikroTik, maybe not the one Andrew was saying due to price, but we can fully control and integrate with it. Yeah, okay. So this is a critical point. It's not necessary to build everything. I mean, it's nice, but what I like the idea of is integrating with existing things like pfSense, for example, the example I used earlier, so that we don't have to build things from scratch. We can take something that's existing, which could be an existing managed Ethernet switch, and talk to its API and control it that way, and then pull it into the management console so that it becomes part of the ecosystem. Gerald says you had to see how deep the rabbit hole goes. Yeah. Killer Geek says for that VSC 7424 you need that DDR memory. It's part of the vCore 3 CPU in the switch, and it needs software to run and control the switch core. Yeah. Okay. Tura says estimated over 1,200 switches produced since start of the project. Okay, so White Rabbit switch. Maybe this is something to investigate. White Rabbit switch. If there is an existing, of course, open source project, there's no need to reinvent the wheel. White Rabbit switch. 7 sols. HomeWiki projects White Rabbit switch. Let's see what this is all about. White Rabbit switch hardware. It's an open hardware design. Yeah. I don't know what the White Rabbit project is. I should check that out as well. But if someone has already done an open switch design, that is really, really cool. Alright, so what have we got? On the left, it's got, what is this? PPS clock out 10 megahertz. What is this? There is some extra stuff there that you do not normally see on an Ethernet switch. So PPS, I guess, is pulse per second. 10 input PPS and 10 megahertz, clock 1, clock 2. Yeah, there's some unusual stuff going on there. A couple of cooling fans. So this board on the left looks like it has some extra functionality. This board in the middle has got all of the SFP cages. 10 megahertz output, software configurable, 10 megahertz input. Yes, connected to an ARM CPU, so it's got an onboard ARM CPU, and it looks like it's got an FPGA on board as well. 1 by low jitter clock generator, 25 megahertz BCXO, at Mel, it's got a SAM 9G45 CPU in it. FPGA JTAG connector. That's got a lot of stuff. A lot of things that I don't even know what the purpose of it would be. So let's have a look at repository. No, first I want to see what White Rabbit project is. White Rabbit provides a sub-nanosecond accuracy and picoseconds precision of synchronization for large distributed systems. What the hell? It also allows for deterministic and reliable data delivery. White Rabbit allows you to precision time tag measured data and lets you trigger data taking in large installations while at the same time using the same network to transmit data. Well, that sounds very space agey and rocket sciencey. Yeah, I can definitely see applications for that. That would be really useful in a lot of scientific experiments and things. Being able to use Ethernet as the communication system for data acquisition with very high levels of precision of timing. So, yeah, all right, that does make sense. And that explains the weirdo ports that are on the front of this particular switch. So these clock signals and things. But we can ignore all of that. This could still be a very useful thing. So circuit board mechanics 8 years ago. So it's not a recent design. WRSP3. What do we have? Docs, libs, SAMD, mini backplane, mini backplane simple, backplane test, structure. Okay, files for the standard mini backplane, simple mini backplane with 6 ports SFP. Let's have a look at to create a copper mini backplane. Let's have a look at the regular one. I wonder what they've, it's GDOC. Which I think means this is, is that KiCad? It looks like KiCad files. Like in an old KiCad format. Bugs and changes, project outputs. Let's have a look in project outputs. We might get some, I don't know, specifications. SCADOC. Yeah, this is interesting. Definitely worth looking into. It's older than I expected. It's been around for a while. Yeah. Right. What's going on? All for syncing time, accurate time. Yeah, Scott says White Rabbit switch is deep down a White Rabbit hole. Yeah, and Andrew says a bunch of the listed users are research labs that need really accurate times. Right. Yeah, but it could definitely be something that's useful for inspiration. I wonder what speed the thing is. Anyway, this is a project that Yeah, I could totally get lost in this. And never see the light of day again. I really, really need to exercise self-control and not dive down this rabbit hole. I wonder though, I'm curious to, I'm curious to actually have a look at it and see how complicated it is. Download zip, that'll do. All right, I'm gonna grab it and see if I can, open it. If it really is KiCad. What was that? Stephen says, Mitchell, get John a card and he can make a start on a 400, 800 gigabit switch. What's that? There is a PCI timing card, and you can also get, and it links up. It's for sub-nanosecond time sync. All right, open. Let's open that and open that. That. I'm just digging down into it now. I'm going to see if I can open this. I'm not even sure if I've got a recent KiCad installed on here. Mini backplane SFP project open with. No, let's see. KiCad. Do I have KiCad? Yes, I do. Just shows how infrequently I use it. All right, open. Downloads. Don't worry, you'll be able to see this in a moment if I can successfully open it. What's it called? Mini backplane White Rabbit switch, hardware master, circuit board, switch, backplane, 18 SFP. No, KiCad doesn't want to open this. I wonder if this is an Altium design .scadoc. What are the... Gerald says, random squirrel party has taken a left turn to Wonderland. Yeah. Scott says, would have swore we started out discussing an MQTT manageable 8-port switch. Yeah, that is what I want to get back to. Now, design rule check, SCADOC. Yeah, I don't think this is KiCad. I think this is something else. What is the SCADOC extension? Let's see. SCADOC file extension. Protel for Windows. Ah, okay. Well then. Protel for Windows. Not much, not much good to me. Oh, Alexi says that I missed the message above. Okay, what was Alexi's message? Scrolling. How far back was it? Alexi, scrolling. I definitely did miss Alexi's message. I've scrolled way back and I still can't see it. What is it? Sorry, Alexi, I can't see a previous message, so maybe paste it in again and I will try to pay more attention this time. Okay. Scott says we haven't even seen Steve and Steph yet. Tourist says, on a side note, someone mentioned Open Compute. You should look it up. Yes, so Open Compute is the data center project, I think, unless I'm totally confused. I think that's the name of the Open Data Center thing from a few years ago that was Facebook and a few other people working together. Check your Twitter message. Oh, okay. So Okay. Protel is now part of Altium. Funway Book 3, says Alexi. Ooh, okay. I'm just going to jump into Twitter, and yes, I am behind on messages. Lexi said, ooh, so there is one on eBay. Thank you. Where is it? So it's $24. A nice clean copy with light wear to edges. Pages are clean and unmarked. It's ended. I wonder if... it's located in Carrum Downs. I wonder if it's possible. Did it actually sell, or did it just run out of time? I wonder if I can contact the seller and make an offer or something. Right, yeah, it doesn't look like it was sold. It looks like the auction ended. So yeah, thanks for pointing that one out. I'm going to keep an eye on that. Where are we? Okay, back to chat. Yeah, Alexi, sorry, I didn't notice that DM in Twitter, so... Right. So Mitchell says Meta is now pushing the TIP project. Oh, Andrew says, I have Funway Volumes 1, 2 and 3 on my shelf. I'm jealous. Yeah. Oh, and Andrew pointed out, a lot of other companies are involved in Open Compute project now, not just Facebook, but that's where it started. Yeah. It's a few years since I've looked at it. I do remember when it first came out, there was a whole lot of hoo-ha about it, and it was being pushed as a Facebook thing, and it was basically Facebook saying, we are developing these open designs for data centers and data center infrastructure, but yeah, and anybody else can join in, and then a number of other people started participating as well, but I can't remember who ended up as part of it. Yeah, Alexi, I really appreciate that. Alexi said, you said you want book 3, so I've been keeping an eye out for you. Yeah, I hadn't, in the past, I had done searches on eBay and other places, but hadn't found it, and it looks like my timing was just bad. But I will see if I can get in touch with that seller down at Carrum Downs and see if they still have it. Yes. Mad Techie says, I have volumes 2 and 3. Yep. 3 seems to be the hard one to find because it was the last one to come out. It was the most advanced, and it wasn't around as long as the others. So, Mad Techie says, I have book 3 if you would like it, John. Well, I would like it, but I don't want to deprive you of it. So I know it's a treasured possession for many people. So what I will do first, it's a generous offer, Mad Techie, but what I will do first is I will contact that seller on eBay and see if they still have it. And if they do, I'll just buy it from that ad. So the price wasn't too crazy. It was fine. I would just buy it. I am mentally running out of steam. So, you know, I'm in that state where I can feel myself going. Yeah, Austin says, sounds like someone should digitize it for posterity. Oh, it already is digitized. It's up on Internet Archive, on archive.org. But it's just that I would like to have a physical copy of it. So if we go to, where am I? That and that. Why aren't I getting a new Chrome window on there? It's like my keyboard has stopped working. Let's try this. I'm just going to switch to here temporarily while I... Can I type? Yeah, my keyboard is working. Archive.org. And Internet Archive. All right. Funway Volume 3. My keyboard is definitely being strange. Come on. Now E is not working. Volume 3. There. Unexpected error. Archive.org. Archive. Funway. Sorry, this is not the most fun streaming ever. Into electronics. Volume 3. Here we go. I think this is only a black and white scan, but it is there. So this is archive.org's Funway Volume 3. I'm pretty sure there are colour scans of it as well. So the entire book is there. It is... where's Zoom? Yeah. It's not the greatest scan. That volumes 1, 2, and 3. Where is volume 3? This one. Is this a colour scan? Yeah, okay. So this one looks like it might be, well, it's colour. But let's zoom in and see if the actual scan quality is better. Loading, loading. Yeah, I think it might be a little bit better. Yeah, it is. That's a better quality one. All right, so this is Funway Volume 3, scanned in colour on archive.org. So it is online. It's just that having a physical copy is cool. Yeah, Gerald says there should be a PDF download below. Yeah. Right. Alexi said, if I see one next time, I'll just buy it for you. Well, that's very generous, thank you, but I'm happy to buy it myself. I just need to pay more attention and not miss not miss the auctions. Mateki said, I'll send it to you next week. No, you don't need to do that. I mean, I really appreciate it. If you do that, that would be fantastic. But I don't want to... I'm not wanting people to give up their own copies that they are saving, that you might want to keep for your own purposes. Yeah, Tourist says nothing like a physical copy. Yeah. And I do want to bring back those kits. So that's the thing. That's a whole other... I've got so many projects in my head of things that I want to do, and I just can't do them all. There are things like reproducing, or at least reproducing is the wrong word, but making the Funway kits available again is a major project in itself, and it's a whole lot of sub-projects because each of the kits is a project, and in Funway Volume 2 there are 20 of them. So I don't like the it's probably just because it's not what I got used to, but I prefer the original Funway artwork with the, you know, the cartoony sort of look to it. This is what it looked like when I got it, and then they changed it sometime later to go for this look. And I don't like it as much. I prefer the original look. What was I doing? I don't know. This is a sign that I really should just end this live stream. And what's my data looking like? So I'm still on Yeah, that data is probably out of date. Yeah, and Austin says it's why I keep a list on a sticky note on my desktop. I work on things piece by piece based on mood and budget. Right. Yeah. The problem is that I don't get any of them done, and I really need to get some done. Chip says time for 3D printed and reflow oven cooked pikelets. Yeah. Oh, this is in relation to the too many projects thing. Imi said, same here, the neurodivergent urge to do all the things whilst doing none and not many. Yes, that's me. Yeah. All right. I am seriously fading. I had a big day yesterday with building the cleanish room. Made really good progress. There's a whole lot more to show you. Oh, okay. Before I wrap up, there is another thing that I'll talk about. Talking about showing you. So, hang on. I'm gonna bring up some photos. I think. Oh, it's so annoying that keyboard is in front of me. Where are we? I don't even know. Where am I? Dropbox. They're probably not even synced. Alright, I'm just going to open Dropbox on my phone because I took a couple more photos last night while I was working on it. Dropbox. Here we go. Okay. I'm going to open a few pictures and show you where it's currently up to once it syncs. Oh, excuse me. I need to cough properly, but I'm trying not to because it would sound terrible. No, I've got to do it. All right, that's temporary relief. Is Dropbox uploading? No, it's not because my battery is too low on my phone. All right. Oh yeah, there it goes. It's starting to catch up. All right, this picture. It's not a very exciting picture, but this picture here, which is a little bit hard to see, I'll zoom out. This is the corner of the clean room where the rack goes, where the Cray server rack goes. And you can see the side of the Cray rack there. I wheeled it out of the way because I put the sheets on the wall here. You can see there's one large sheet that fits up around the beams, and then there's the little strip along the bottom that fills it in. And this, you can see the glass here. This is in the clean room side of the glass wall, and you can actually see through there and then through the other door into the back of the roller door in the front of the factory. So this was the last photo I took last night after I got that up. And there is, where is it? This photo. Okay, so this is more progress on the cleanish room. There's the back wall down there. That's the one that's been there for a little while now, and you would have seen pictures of previously. The pick and place machines wheel down into the back side to get them out of the way. You can see the Bernie Boy reflow oven, and then these two walls are now in place. There is that back sheet that has been up for a week and a half or so, 2 weeks now, and you can see another sheet. So this is another 3.6 meter sheet. So that's 7.2 meters from that back corner to this front leading edge here on the left. That's a 7.2 meter span, and you can see the Z-Wave power boards attached to the wall. They are all the power cords for the power boards go through that wall, and then they plug into normal power points that are on the actual factory wall. So basically what I'm doing is I'm building a box inside the factory for the cleanish room, and these power boards are attached on the inside of the box, and then their power cables go and plug into normal GPOs. So I'm not doing any like any mains wiring directly on here. It's power boards plugged into power sockets that are on the wall. But the end result looks really cool because I end up with the Z-Wave power boards attached to the wall. They're just stuck on with double-sided tape. It's this crazy, really super strong double-sided tape that Lachlan has, and just little sections of it. You push it on, apply pressure for 30 seconds or so, and it won't ever let go. It's really strong. So that gives me, each one of these is a 6-way power board. So, and then there are another 2 that, there's one you can just see the edge of there behind that pick and place machine. There's another one back in the corner, and then there'll be another one down here. And so there'll be 6 of those 6 outlet power boards along there. And each one of those sockets is individually addressable from the automation system and power monitored as well, so I can tell how much power is being used. So it's starting to come together. There's still a bit to do down this left wall. There is still part of the right wall to do, and I need to line the ceiling with something. I'm not even quite sure yet, but as you can see, it is getting to be close to a clean room, which is really cool. It's very, very close. Yes, it's a box in a box. Yes, Emmy says, Bernie Boy needs a cool label sticker thingo. I have a sticker cutting machine. Awesome. I have been, is that like a vinyl cutter type thing? You know, like one of those, what are they called? Like a cricket cutter. I've been wanting to find someone with one of those. I actually do know a couple of people that have got vinyl cutters, but I need to do a Bernie Boy sticker to go on the Bernie Boy, and I also want to do a really big version of the Cray logo to go onto the side of the Cray server rack. And the there was a name. What was, someone came up with a really funny name for the Bernie Boy, for the company that makes it, the brand. It was like the Steve, I wrote it down at the time because it was funny and I wanted to use it. It was something, and reflow oven manufacturing concern. Something like, you know, the Steve Glorious reflow oven manufacturing concern. Oh, Emmy says, yes, you have I have a Silhouette Cameo 3. Cool. That is exactly the sort of thing that would be really useful. Nice. Thanks, Emmy. We'll arrange some labels for things. Andrew says, I visited a maker lab nearby with my kids during the holidays, which has a vinyl cutter and a t-shirt press. My kids all now have 2 cool self-made t-shirts each. Yeah. All right, so that is the current state of the cleanish room, and it is starting to look really cool. Also, I got an email a while ago which I totally overlooked and then just followed up this week, and it was an offer of from someone to supply some lights, and I'm a little bit hazy on what it's all about still, but it looks like maybe I'll be able to get some lighting to go in here. And the description was that the lights were based on the LifeX platform, but I don't know what that means, whether they are LifeX lights or third-party lights that communicate with LifeX, like they use LifeX modules maybe. I'm not sure, but anyway, I want to have a lot more lighting in here. I've only got about half as many lights in here as I want to have. There are still shadows and things, as you can see in that picture. I want this to be really, really well illuminated. And so the other thing, Aaron, I had noticed. So thanks for the £5. I have. All right. So what Aaron is reminding me about I won't go into all the details of this, but it's a DNS issue in relation to oxrs.io. And Aaron, I had not forgotten about it. I had actually done something about it. The issue was the oxrs.io domain needs some changes made. And I was trying to arrange redelegation to Aaron's name servers so that he could then manage the zone entirely. And there has been a it's a complicated story in relation to the way the domain is registered, because the .io top level domain is done, it's handled through nick.io, and then that is managed through name.com. And I've got an account at name.com, but name.com tell me that they do not manage the oxrs.io domain. And I've been going around in circles trying to find someone that will actually acknowledge that they have some control of the domain. Anyway, yes, Aaron, I will keep trying to get you access to control of the oxrs.io domain. And I have a feeling that what it might come down to is just giving you admin access to my Linode interface so that you can manage the zone that way rather than through your own name servers. But in whichever way it happens, I will get you what you need. And thanks for your patience on it. All right, I am going to wrap this up because my brain has definitely faded. But what I'm going to do is, by making that, the oxrs.io issue, the most recent thing in my head as I'm wrapping up, I am going to follow that up right now, Aaron. I will not let it drop. I'm going to end the stream, have a drink, and then try to figure out how to get you admin control of that domain in some way. So, what am I doing? Okay, I'm going to go. Thank you very much for the rambly, the rambly stream today. And I will talk to you. Oh, the one final thing was, pizza. Thanks, Gerald. The one final thing was more barbecues. Yes, I am going to do more barbecues, thanks to Keith's donation of the super barbecue. And I was talking to Andy a couple of days ago about when to do it, because my general idea had been I would like to do a barbecue once a month, and that may be a little bit too frequent, I don't know, but anyway, I'd like to aim for once a month. And my initial idea was to do it on the first Sunday of the month so that it's a regular thing, people know when it's on, and it doesn't have to be a question of, is it going to be on this, like on now, or do I need an invitation or whatever. People who know the address and know where I am can turn up and know that it's going to be on. However, first Saturday of the month is a social evening at Connected Community Hackerspace here in Melbourne. And having a Hackerspace social event on the Saturday and then the barbecue on the Sunday, two things on adjacent days, is probably too much for people. So what we've been talking about is maybe doing it on a different, like on an offset day. Maybe second Sunday of the month or third Sunday of the month. Now technically today is second Sunday of the month. Next Sunday is third Sunday of the month. So I kind of could do a barbecue next week, but that just seems too soon. I think what I will do is my inclination is to go second Sunday of the month. So I think what I'll do is aim to do the next barbecue on, I'm just going to pull up where is my cursor? Where is the cursor? There it is. Pulling up a calendar. So right now we're on Sunday the 14th. What that would mean is that it would be Sunday the 11th of June would be the next barbecue, which is an unfortunate time away. That's too far. I want one sooner. Maybe we can have like kind of an off-schedule one sometime as well before we settle down into the regular schedule. So, yeah. All right. I think I'm going to settle into a schedule of second Sunday of the month. Mad Techie says, when is the barbecue tour? Yeah, barbecue tour. Sounds like a good idea. Okay. Brain fade. Okay, point is, I'm going to do more barbecues. I'm going to make it a regular thing, and it would be really cool if people wanted to come along. So, let's do that. But first, I'm going to wrap up this live stream, and I'm going to try to fix DNS for Aaron. Okay. And with that, I'm going to wrap up, or I'm going to totally forget that that's what I was meant to be doing. Thank you all for coming along. I have no idea why you do. I wouldn't. But maybe I'll see you all again next week. Hang in there and go and make something awesome. See ya.